All right, now the next question is, a stone is thrown vertically upward with a velocity of this at an angle of this to the horizontal. Calculate vertical component of velocity, and again calculate horizontal component of velocity. So this is like resolution of velocity. If I have a velocity that is thrown at an angle, it means that there will be a vertical component to the velocity, and again there will be a horizontal component to the velocity. This is also applicable to force. You can also resolve force into vertical component and the horizontal component. Okay, now this question is coming under projectile motion. Okay, so now look at this. Now they said a stone is thrown vertically upward with a velocity of this at an angle of this. So the stone is thrown vertically upward. Okay, vertically upward, so it maybe move up, then at a point it started producing a curve that the angle of inclination, let me take it there, is 30 degrees. So this angle is 30 degrees, and the velocity at which the stone is thrown up is 5 meters per second. So what is the horizontal component of the velocity and what is the vertical component? As you can see, this is the vertical component. I can call here Vy, and this is the horizontal component. I can call here Vx. So if I should bring out something of that nature, I'll have something like this. This is the velocity, 5 meters per second. So this is the vertical component Vy, and this is the horizontal component Vx. So I can still trace this. I can still trace something like this. I can still trace something like this. So this line and this line are parallel lines, so they are equivalent. So this place can also represent my Vy, which is the vertical component of the velocity. So what we do here is nothing but to apply SOHCAHTOA. Remember that the angle here, they told us that it is angle 30 degrees. Okay, so if I apply SOHCAHTOA, so here, for vertical component, that is the opposite, horizontal component, that is the adjacent. So which of this formula has opposite for us to get the vertical component? Because the vertical component first, so opposite vertical component. So here we have that sine theta is equal to opposite over hypotenuse. So hypotenuse is what is representing the velocity of the object thrown up. So here we now have that opposite is the Vy. So here we have that sine theta is equal to Vy over, now what is hypotenuse? Hypotenuse is the velocity, which is V. So which means that Vy is equal to V sine theta, where V is the velocity. Now if we're looking for Vx, so which of the formula will enable us to get it? So if you look at this, Vs is at the adjacent, so cos theta. So we have that cos theta is equal to adjacent over hypotenuse. So cos theta is equal to, our adjacent is Vx over our hypotenuse is V, which is the velocity. So it means that Vx is equal to V cos theta. So this is to tell us that anytime we are looking for vertical component of velocity, this is the formula we should use. And anytime we are looking for horizontal component of velocity, this is the formula to use. It is also applicable to force. If I'm given a force and I'm asked to get the vertical component and horizontal component, what do I do? For me to get the vertical component of force, I multiply the force by sine of the angle it is inclined to. Horizontal component, I multiply the force by cos of the angle it is inclined to. So this is for horizontal, anything horizontal. And this is for anything that is what? Vertical. Both vertical force, vertical velocity, all those stuff. You can just resolve it in this manner. Okay? So now, what is our vertical force? Our Vy will now be equal to what? V. What is our V? 5 sine. What is our theta? 30. So here we have 5 sine 30 for our vertical velocity, and for our horizontal. So 5 sine 30 will be 5 times sine 30. This will give us 5 over 2, which is something as 2.5 meters per second. So what's our horizontal? Vx will be 5 cos 30. So 5 cos 30 will give us 4.33 meters per second. So this is our vertical velocity, and this is our horizontal velocity. So we have resolved this velocity into vertical and horizontal components. So that's how to do it. If it is force, you still do it the same way. Okay, as simple as that.